to the 4 minute set. Time now. Is it recording? Yes, it is recording. Big ups to me. Yes, my notes here. Oh, this video is self-explanatory. I mean, this should be self-explanatory, but but that's what I'm doing here. So, in terms of self-explanatory, it's basically what we're doing working today. And, I'm not going to focus on anyone. I'm not going to focus on. So I've got the blackboard behind me. Today's video is on the NSIGII OBIVOX repository, OBIVOX voice repository. But mathematically speaking, is the quantum implementation for it. Define the things now. So, OBIVOX repository is basically on github.com/Oscar, B for Bravo, I for India, B for Violet, O for Oscar, and OB Nexus, O for Oscar, B for Bravo, I for Indigo, N for November, E for Echo, X for X-ray, U for Umbrella, S for Sarah, / O for Oscar, B for Bravo, I for Indigo, V for Violet, O for Oscar, X for X-ray, OB voice. Self-explanatory because you've got natural language and you've got OB voice, and you've got things you want to do in the system of natural language. Well, this is very important before, so you get a copy of OB voice, which is a polygraphic system for codecs. Codecs are coder, and encoder. So you get a codex, you get an encoder, and you get a decoder. So OB voice is a polygraphic codec system, decoder system. Various polyglottic file format. That's what it is. But this is connotation of the system. Here, what I've got here on my sheet of paper on the blackboard. So on the blackboard, you see the encoder / decoder. You get a trident pointed to the codec system. But here, my note says, basically, I got something on the screen. So you get the fermions as force carriers. Fermions are force carriers. Fermions including the electrons, neutrinos, electrons which are, if I remember correctly, are the electrons which are categories of fermions that have charge. No, they have mass and charge. They have charge. And the charge represents the electron, the muon, which is 100, and the 12, T triangle alpha umbrella. But they are in our dimension, they're not universe, they're called force carriers. So I call them force carriers, they're about poly low. What about the simple the subatomic ball is not computers compute over. They work on the smallest scale stuff, the granularity of our world. And to make sense of this all, you can understand the observation, the icon force carriers because they hold force, they force the voice propagating in the air. It's explained in many ways, but the fermions hold a force over a medium, and the medium can be sound waves or light waves, LiDAR, sonar, whatever which contains a laser, lightning diode, sound, like a sound. They can mean something, and they share a common codec. So the codec is what to decipher the system of because it's very close to everything can have a codec. Where you get nuclear as and for my kilo, O for Oscar, dash O for Oscar, S you get codec, So you get coder decoder of OB voice. You get a radio where it's going on. It just gives you the size of the world around you, so you can start making sense of your stuff and start expanding your qualia, which is like your physical mind and the information around you is up to you to have, but it's basically what's the proof? System. It's going to be focusing on the bosons. The bosons are literally the gluons and the Higgs field. Now, I'm not really sure about the Higgs, but I refer to them as quantum foam. Quantum foam friendly. So, yeah, the Higgs boson appears in. Yes, 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 yes. The Higgs field. So the Higgs field is in the Higgs boson there. But when the particle accelerators are collided, you get a Higgs boson, which was a force carrier, which was a mass. It had a mass, so that's what was being measured. So it had a mass, and because the two particle fission, no, fusion happened in the laboratory. Bell, I don't know. I think it was Bell. I don't know laboratory anyway, but somewhere in Germany or something. But the Large Hadron Collider, wherever that is in Germany, because I wasn't there, I don't know, but I'm not a historian, but I'd like to know where it says that what happened, but I'm giving what I remember. So Higgs boson is basically it has a mass. So I'm gonna give you a definition of what's happening in my framework of organization to start understanding the Higgs boson. So we got the weight plus, and we get the weight minus, and W minus. I don't know the sign. I don't know what it means. I'm trying to understand the boson. B for Bravo, O for Oscar, F for Sarah, O for the Oscar, F for Normal, F for Sarah. As part of the particle systems that make up the that you have like a system of reaction. I'm literally doing as mass. They have mass. You got the gluons, these are holes fixed together, and you got the hits, these are the held. So the gluons hold this together in the electrical of bosons, the Higgs levels actually held together. But I think the held I believe the fusion experiment of the electrons that they find that find to the it's spread around 8 times. When you speed able to get light speed, because it's a correlative. You get the speed of light, you get the force at the speed of light. So I'm believing my hypothesis is that because the Higgs boson was formed 8 times in the hadron collider, correct me if I'm wrong, they achieved light speed, which is the electrons, moving in five in the same direction, but going in the opposite way, because you get like a spin, you get like a little spin. So they have two other directions you can take, right? And when they met in the center, they had the mass of the sun, the mass of the light in the sun. So the boson did not come from anywhere. It was hit together. So question was spun so fast that the force did become mass because they collided. But the force was really at light speed. So because in from the sun you get light. So because light is electron. They don't interact that way via fission or fusion. So you get a nuclear reactor. Well, you can have fusion or fusion. We don't have that kind of natural speed. So the speed is equal to the mass, and the mass is what after the collision effect of the electrons that brought the weak measurement of the mass of the Higgs boson. The Higgs boson is a certain principle of a dimension. So dimension principles, So doesn't matter the false mass operation in the universe, within the relativity. They share isotropic, that is isomorphic, and tomographic, topological, sparse structures that obey the same principles of the dimensions because there are still forces that are involved in that system and mass too. So, wait, am I doing right? So, yeah. So, the weight plus, I believe there's the W plus, I don't know what this is, but I'm going to W plus and the weight minus the big letters of W represent what I believe are pions. I don't know. But you get the same thing. You get photon. A photon is can be electromagnetic. So it just has some magnetic properties. It's basically electromagnetic until it interacts. But that can be isotropic. Between the structures, not necessarily isotropic, but isomorphic evolution between the photon and mass space. So my video here is on the CB OBIVOX. The signal force field, which are fermions, the bosons, which are mass, hold mass. But the mass one tends to hold mass. I'm trying to encode the system into a Pauli equation. I don't know how to use that, but that can be translated into something that eigenvalues for mass. So, like I said before, eigenvalues are, like I said before, eigenvalues e to the power of e sub ijk. Okay. E is, let me do big E. So, it's a diagonal of E. So, the big E is an eigenvector. An eigenvector is something that holds nothing. So, do you work on the, this is my model of it anyway, so I'm not really sure how to do it. So, I'm going to make it up right now. So, I'm going to do it. So, effectively, E is an eigenvalue that's equal to the I, E, okay, E is a summation of I, okay, E sub, so E sub ijk, E sub ijk is equal to where I is so big E, capital E, so IJK is equal to the summation of let me look at my office. So I'm trying to write down the equation for a measurement of nothingness. Nothingness is basically the field of so this is the propagating of something. There's something we can measure. We just observe the state of it. We just need environment. So the eigenvectors represent the measurement of nothingness, stillness, stillness or emptiness, feeling empty. Well, feeling empty is the dimension of the property, but to feel empty, you have an observer. So an observer has to feel something, and that empty, physically feel like boring, like so the notion of bored notation with the alone, the same. So the notion of notion of bored, if they're alone by themselves, you should be enjoying the notion of bored. This will ask people that are bored. It's very positive. You just think they're bored. You think they are, but they don't have to do anything. So that's very positive. So you get a piece of IJK, which are IJK IJK have a dimension. So I is equal to I is defined as the eigenvalue of I hat J hat and J hat the eigenvalue of x y z x x equals to so you get the relationship, you get so controller, to remember this properly. Well, I have equal to conjugate pairs. I have so you got the conjugate pair model. So you have IJK, which are indexes, and IJK, which are the dimensions of indexes, like IJK that operate on vector or like the Boson model of the bosons from here. So they have like one good width plus, let me just try to do it without knowing what it is. So and with super plus root minus. This and you get the z0, which is the z0, which is really the axis. But, the width is all dimensions of the system, but I don't really know. Yeah, so the photos are just to say. So I know the photos are the blue ones. So the blue ones have to hold it together. They don't hold this together. They hold this together. So I'm saying the each IJK is with the summation of R E where E where for row X Y Z there is an element element that defines a range between uh, um, uh, W minus is a limit for subset to W minus and plus, W minus plus. So this equation says each of big E, which is eigenvalues, IJK, is continuous summation for all X, Y, and Z corners. There's an element that has a width, there's a width and a width plus or minus Z. Z zero. But the width is basically the dimensional width of the system. So so this was my formula here. I've tried to do it, guys. Why homeless? But so you get the fermions as force carriers, the bosons as mass holders, but because this was supposed to be, I'm not sure what, but I'm trying to use it now to try to see what it like something, I'm not sure what it is. But the thing I'm saying is you got a relay system that can model this kind of change of width. So the width is basically the change of the dimension, and the width is basically the width. So the width is basically the change in a specific dimension. And dimension have quantities. So you have a width in I hat, probably times x of x. But the same width can be attributed to z and y respectively. For example, you get x sub j, where I and j are indexes, but j is basically j is in axis y, and that y holds the relation of the space. So j is equal to an index of so xij is like a complex system. So you get xij, you get two I plus one. So if I write down this in the way, if I define xij two as 3 by 2, so xi is two main vectors here. I'm just modeling this myself. So xi has so x sub I has a dimension. A dimension is basically a vector. And the vector or the scalar. So the dimension is what j. If I takes priority, if xi is not ji, unless you get some because what is fine. I'm finding that so if you get xi x sub I hat, you get a complex number I 2I 2I imaginary number 2I 2I 3 and you get 3I as a row vector. You get the same get the color model. So you get I can be 2I 3. And then you get 2I 3. But this is a row vector conjecture. And then you get J. Now J has to have the same as J is just like say that J is still a imaginary unit. So 5J 6 row and column conjugate. Because they can subtract and plus each other. We have you get 2I plus 3, you get 2I minus 3, you get 5J minus 6, 5J plus 6, you get 5J minus 6. It's basically a system of resolving kind of width. Where is the width? Now, I'm just still theorizing, but the goal is to have the sparse model isotropicate over a series execution values, which are called the hat model. Yeah. So, measure what is the nothingness here? What is the eigenvalue they share? This sparse structure. So, what is the width? What is the eigenvalue? And the eigenvalue they share xi between I and j is, I'm still theorizing, guys, 2I, the share, so you can write down 2I plus 5j, and this is all complex numbers. 2 plus 5j, you get 3 plus 6, and you get 6, 7, 8, 9, you get 9, 5, 6, 7, 5, 6. So you get 2I 5j plus 9. And yeah, and this is basically the units of ij can actually be compressed. So you get 12 or minus 9. So you see, satisfy this equation, this first one tries to do is you get 2I, so you get 2I plus 5j is 5, 6, 7. 7, no, 2I 2I plus 5J uh, equal to I can write it equal to 9 for it's a stable. So constant for the what? So 2I plus 5J equals to 9, 3, 6, 7, 8, 6, 7, equals to 9. And this equation will tell me what's in the width of the system. The dimension of the shell is 9, but the 9 is because there's two systems here. So I'm going to go here and see whether this is right or wrong. So, so I'm going to go here. So, so this equation, I become right, or, the one on polar system, or polar axis two, on polar axis. So I'm going to try to solve it through this. So the first thing is the eigenvalue, ijk. It has a subset, it has a solution of for all x and y, z, which is element of width plus minus z0, which is like the width of the system. So you get a system of 2r plus 5rj equals 9. So they have a shared mechanism. Now you can use the shared 9. So I can do 2r divided by 9 and 5j divided by 9, and that will give me the Chinese method of solving of solving equations. But I can just because they have the Chinese way of doing it, which is like a 2R with a calculator. Where's my calculator, guys? One second, guys. So you get 2R. So the 2 is of R. So I'm going to try to do right now because I don't have a calculator on me. But I'm going to try to finish. Try to finish myself up again. So 2R plus 5J. So you get it divided by 9. But this share, the common denominator this share is not, you don't share anything to come on. So 6, 7, 8, 9. 6, 7, 8, 9. 2, 2, 5. Oh, 5, 6, 7. 5, 5, 6, 7. I'm going to so you get 2 I divided by 9 plus 5I divided by 9 is greater than, is less than whatever on the right side. The same one wants to do with equality, but I don't want to do that one. So I'm going to try to do it here. I'm going to try to solve it out. So I'm going to try to relate it to the code system. So you get 2I with 5J equals to 9. You get 5 divided by 9. So 5 divided by 9J. You get 2 divided by 9I. And that's equal to 0. So the answer is 2 divided by 9 J. So 2 divided by 9J. And 5 divided by 9 equal to 0. And that's the unit capital dimension, the share before equals 0. Because you have to accumulate the numbers. But the imaginary make sure there's something there over the system. But this is a simple example. Notice this is not 3, this is not x, y, z. It's just like x only, x and j. X with attributes a, y, and j. And attributes are properties that can give you traits in the real world. So once the both interact, now you get this shared reality, you get this shared computation. When this meets in the middle, and you get the math, but this meeting the dimension is shared. 2 divided by 9, or 2 divided by 9, 2 divided by 9, comma 5 divided by 2 divided by 9I, where I is the imaginary unit, and 5 divided by 9 equal to 0. So you get the eigenvalue of your thing. So let me zoom in now to show you this properly now before I end this stream. Let me just go to the camera. Oh. So it's kind of beautiful actually, but it's because you can use it to measure out yourself. My goal is to take this equation and see what it applies. Get some peer review on it, but see whether it's making sense. But this one thing, it should make sense, guys. Peace. I'm a hip teacher. Peace. But it should make sense. So you get E, I, J, K elements for all X, Y, and Z. Which sorry, for all X, Y, and Z, there's an element where, which all the defined elements in the boson model, and the boson hold mass when they react. And that's the NSIGII OB voice system. So it's a coder and coder system for mass and force. Determinant of the measures of mass and force, respectively, given the width, which is determines the acceleration of the positive, negative, or charge. The charge. You get the width is the positive charge. So if you this negative is a charge, this is charge. The charge level is strange, which are properties of fermion. So there's shear, charge, and strain. So you get a charge, which is like the little charge, of the symbolic charge of the system, via the axis, the model, which is the axis of the x, y, z. So you get the charge positive for proton, negative for electron, and z for zero. The z determines the width of a measurement in space. So this one is for quantum tunneling. So you use z0 to the value of quantum tunneling. Okay, thank you guys for watching this video. Um, like, share, and subscribe, and hope you like the video. I'm gonna upload it now. Oh, and the audio voice repertory is basically for you to have real time O for Oscar, B for Bravo, I for Indigo, V for Violet, O for Oscar, X for X-ray. Real time, or mean to have real time transcription and via NSIGII symbolic expression, symbolic intent files that will model dimensions quantities as attributes of loneliness, sadness, madness, craziness. Basically, if you write anything to the system, similar to start detecting your signal, and what you're feeling in that space in that time. So it's a human operating system that knows via the trading. So this system, so I'm holding 2 divided by 9, 5 divided by 7 equals 0. Because that's the equals 0 equals I and J. Equals I and J respectively, not 0. Thank you guys for watching.